my name is Zahra and today I will present my research on circular design strategies, focusing on the use of reclaimed steel in structural systems. This study uses the Crowndale Centre in London as a live case study to explore sustainable retrofit solutions in construction. The built environment is one of the largest contributors to climate change, accounting for about 37% of global CO2 emissions. In the UK, commercial buildings alone contribute 20% of national emissions. The UK is obligated to cut down on carbon from the building sector. Therefore, as regulations hold strict positions, a reduction in embodied carbon has become a significant part. Since 80% of buildings that will exist in 2050 are already built, retrofitting and reusing materials is a more sustainable approach than new construction. This research investigates the feasibility and benefits of using reclaimed steel to reduce embodied carbon and calculate it with one-click LCA tool. The focus is on the Crowndale Centre, a London office building, assessing how parts of the existing steel structure from demolishing top floor can be reused for rooftop extension while meeting the safety and sustainability targets. Circular economy promotes industrial systems that are regenerative. A key principle is material reuse, which can significantly reduce embodied carbon by lowering reliance on newly manufactured resources while cutting waste. So the first step is assessing which elements from demolishing floor can be reused. The steel elements chosen in this project as it meets circular economy principles. Reclaimed steel offers many advantages. It retains original strength, can be disassembled and resized, and reduces waste. The inventory table is assessed for the steel elements in this project, but before steel can be reclaimed, the existing structure must be assessed. The steel members are inspected for damage, corrosion, or deformation, and only elements meeting safety standards can be reused. In this project, the upward extension that is designed to add 3 floors to the Crowndale Centre required about 100 tons of steelwork. Designing smaller grids from 5 to 7 meters is more beneficial because there will be more flexibility to find the steel and it can be located more easily in the design rather than larger beams. Through analysis and structural considerations, 21 tons of required steel can be reclaimed from 4th floor of the existing site to use as columns, which is shown in red. As cleaning or easier stages can be done inside, but testing or cutting big pieces of steel cannot be done in the site. So the cost of transportation, testing, painting, and reconstruction will be added. Cleveland Steel and Tubes is considered a place for the reclaiming process, which is in the Yorkshire, as no other place in London can recertify the reclaimed steel, which these steps also increase the time and labor. These diagrams illustrate the comparison of embodied carbon between 4 different strategies, assuming new steel and then reclaimed steel from stages A1 to A5, which include all transportation and site construction. It shows the challenges of transportation for reclaimed strategy. However, the amount of embodied carbon for new steel is nearly 4 times more than all reclaimed. This highlights the significant potential of material reuse in reducing carbon impact. Reclaimed steel sections from old buildings into new structures, if done appropriately, can have a valuable effect on reducing carbon emissions by eliminating energy consumption in the process of remelting the steel or in the manufacturing of virgin steel. Although challenges exist, the long-term environmental benefits outweigh the obstacles, so the construction industry can make significant progress towards sustainability goals by using reclaimed materials. Thank you so much for your time and listening.